The book Consciousness Explosion, in a way, is a similar theme to my friend Ray Kurzweil's book, The Singularity is Near, right? The sequel to his 2005 book, The Singularity is Near. And I guess at some point, Kurzweil or his Mind Upload will come out with The Singularity is Here, right? And then next will be like Singularity passed by, and here we are doing the same old shit, right? But with better gadgets. So what I'm talking about in the Consciousness Explosion is basically the path to the singularity and beyond. But I'm trying to take a point of view more focused on states of mind and experience than on the gadgets and the underlying algorithms and technology.
We've spoken a number of times. And yeah, I wanted to hear about the book. Although I saw on Amazon it's $100. So
Well, this paperback is cheaper, I think. But yeah, the color version is more expensive. But there's a free PDF you can download from the consciousnessexplosion.ai website, so you can get the book for free, and the Kindle version is $10 or something. So there's
okay,
that. The information is made to be free, but if you want a big fat book with a lot of pretty color pictures, it just still
yeah.
costs money for ink. That's all.
Could you start by introducing yourself and give some of your background and a list of the various projects, sort of in the order of their importance?
Yeah, I'm Ben Goertzel. I'm originally a mathematician, but I've been doing AI since the late 1980s, since long before it became such a popular thing to do. I introduced the term and concept of AGI in, I guess, 2005 in a book titled Artificial General Intelligence, and I've been working on both R&D aimed at building general intelligence and applications of AI in diverse vertical markets over many decades. Among various other things, I led the software team behind Sophia, who was the first robot citizen, a humanoid robot made from Hanson Robotics in Hong Kong, where I was chief scientist for a number of years. Since 2017, I've been CEO of SingularityNET, which is the leading blockchain-based platform for decentralizing AI. And we've recently done a tokenomic merger of SingularityNet with two other blockchain AI projects, Fetch and Ocean, making me now the CEO of the ASI Alliance, the Artificial Super Intelligence Alliance. So that's a sampling some of the things I'm engaged with now. I'm also dealing with a lot of AI application projects. We see behind me on the wall the Desdemona robot, who is the lead singer of the Desdemona's Dream Band, where I play the keyboards, and we've got a lot of AI generated singing and music and so forth going on. So now, yeah, it's an incredible time to be in the AI field, right? Both in terms of AGI R&D and in terms of just applying AI to all sorts of practical things.
Yeah, we have spoken before. I don't know if you remember, but I'm a bit of a skeptic on Sophia's contributions to AI. I think it creates more confusion than anything. But we talked about that last time. Um, I'm interested in the book because I've been talking to people. I had Stuart Hameroff, who's
Uh-huh.
working on microtubules with Roger Penrose, or wrote a book on it with
Yeah,
Roger.
yeah, yeah. I know Stuart moderately well. I've met Roger a couple of times, and also James Tagg and others from Penrose Institute, and so
Yeah,
I'm fairly familiar
yeah.
with that
So
line of thinking. Yeah.
yeah, I wanted to hear your thoughts on, and unfortunately, I haven't read the book. But I wanted to hear your thoughts on, well, first of all, the premise of the book, if you can tell us the premise of the book, but then on all of this talk about consciousness surrounding artificial intelligence, which has caused a lot of excitement and again a lot of confusion.
Yeah, I mean, the concept of consciousness has caused a lot of confusion, even setting aside artificial intelligence. So
Yeah,
it's hardly surprising the intersection of consciousness with AGI should confuse people even more. I mean, we don't have a solid understanding scientifically of what consciousness is, right? So I mean, we don't have a scientific refutation of solipsism, of the idea that only I am a conscious being and all the rest of you are just simulacra put here to alternatingly amuse and annoy me, right? So I mean, when we don't have consciousness even nailed down in the human or animal or plant realm, right? So
right. Yeah,
I mean, like, does a tree hurt when you chop it down, right? Does a
yeah.
fish hurt when you hook
The,
it? Right? So,
the best definition, and I can't remember who came up with it, but that it's consciousness is what it's like to be something. Like, what is it like to be a bat? I think that
right,
was
right. But then you had quite renowned people like Daniel Dennett saying, "Well, that's all a bunch of rubbish, and the whole concept should be thrown out." Right. So I mean, I'm just saying it's a deep topic. I have my own fairly strongly held views on it, but it is an unresolved topic from the standpoint of scientific consensus, even outside of the AI domain. So then,
mhm,
when you introduce I mean, all the confusion about consciousness propagates over to the AI domain, right? So I mean, you have people like Dennett was who are like, well, the human brain is in essence a biological automaton, and it uses this language of consciousness to describe some things that it's doing. But this whole notion of qualia and experience is a bunch of blah blah blah, pretty much. And then you have folks who are panpsychists, which is more the direction I go in, who think everything in the universe has some
right,
element of consciousness, which is just manifested differently in different kinds of systems. And then I mean then you have folks like Hammeroff and Penrose. Yeah, they think conscious experience is a real thing. It inheres only in certain kinds of matter and not others. And then they have a particular, rather out there theory of what kinds of matter can manifest consciousness. Like you need special quantum gravity dynamics to manifest itself in bio nanotech. And yeah, so the philosopher Galen Strawson, who you're probably familiar with, he has a book called Physicalism Entails Panpsychism, where he's arguing if you believe the world is physical and everything is physical, then you should believe everything is conscious. And he tries to argue that any other position is logically untenable, which on the one hand I like his argument. On the other hand, I'm not that much a materialist. I don't believe everything is physical in like a strong foundational sense anyway. But all that confusion propagates into the AI world. So then people are like, well, no, robots are just machines, just like people are machines. They have consciousness in the exact same meaningless sense that people do, right? And then you have other people saying, well, all particles are conscious, so why aren't the particles inside machines just as conscious as the particles inside humans? Then you have other people saying, no, only certain kinds of matter can be conscious. And it just happens that humans have that kind of matter and computers in their current form don't. But maybe a quantum computer or a quantum gravity supercomputer will. And all this all this is interesting. Pretty much all that philosophizing goes on off to the side. And meanwhile, we're building AI systems with greater and greater levels of of capability. But then even once you get to an AI system which appears to have human or superhuman capability, that won't necessarily resolve all these questions either, right? But there are many views on it. It's like what Roger Penrose believes is that you will never get human level creativity and insight based on a digital computer.
right.
Penrose believes that requires some as yet poorly specified quantum gravity voodoo manifesting itself in how the brain works. Now, many others believe you could get superhuman creativity in a digital computer, but it would still have no experience, right? And so these are all points of view that are out there, and I have my own positions or intuitions, but we don't have scientific proof of any of it.
Yeah.
And I'm more confident. I'm more confident. I know how to build a thinking machine with superhuman capability
Yeah.
than I am that I understand the nuances of how consciousness interacts with or manifests itself from matter. Like it seems like we're going to discover a lot about that in the next few decades.
Yeah. Well, what's the book about? Then the
Oh
conscious
yeah.
explosion. Yeah.
Well, that's a different topic. Yeah, yeah, yeah. So that all this is mentioned in the book, but it's not necessarily the theme of the book. So that the book Consciousness Explosion, in a way, is a similar theme to my friend Ray Kurzweil's book, The Singularity is Near,
Hmm.
right? The sequel to his 2005 book, The Singularity is Near. And I guess at some point, Kurzweil or his mind upload will come out with The Singularity is Here, right? And then next will be like Singularity passed by, and here we are doing the same old shit, right? But with better gadgets. So what I'm talking about in the consciousness explosion is basically the path to the singularity and beyond. But I'm trying to take a point of view more focused on states of mind and experience than on the gadgets and the underlying algorithms and technology. I mean, the underlying technology for building AI, of course, is what I spend most of my time on, right? I mean, it's important. It's highly technical, but it's key. But I mean, you could look at the internet similarly in both ways. Like there's internet technology. I mean, there's all the amazing gadgetry inside this phone that lets it make a nice screen and lets it send information to them from satellites. There's satellite technology, right? There's protocols. On the other hand, there's the internet as a social and psychological thing, as an experience for people to interact with and build cultures in. And that depends on the underlying tech, but it's also in a way a different topic than the underlying tech, right? So what I'm trying to look at in the consciousness explosion is what kinds of mind systems are we building? What kind of mind systems are they going to grow into? What kind of mind systems are we becoming? How does our own state of mind individually and culturally, how does it influence the artificial minds that we're building and the path of of the singularity as it unfolds, right? And so this is really a perspective on a bunch of things that I've talked about at great length in media over the last few years, including AGI versus narrow AI, super intelligence, and decentralized versus centralized AI, and so forth. Because if you look at current commercial AI systems being built by big tech companies as minds, it's pretty scary. Like we're building a bunch of proto AGI autistic psychopaths, pretty much, which are like they're concerned with only one thing: maximize eyeballs, maximize revenue, maximize profit. They don't care about anything else besides that. They interpret all data relative to their one particular goal. They're also built without much focus on modeling themselves and understanding who they are or understanding who they're interacting with, or like building an I thou bond with who they're interacting with, right? So we're building some very particular kinds of minds in big tech companies now. They're autistic psychopaths focused on spying, selling people stuff they don't need, killing people who happen to live in a different country, plagiarizing stuff, and helping Wall Street to steal people's money, right? So I mean, we're building digital autistic psychopaths focused on a few particular ways of accumulating certain sorts of resources, and we're doing this mediated by corporations, which
Mhm.
are also probably autistic psychopaths if you try to psychoanalyze the corporations. But I mean, most corporations are psychopaths by design, right? I mean, they're only concerned with maximizing shareholder value and fuck everything else. You have the notion of a B corporation, in the US, which is supposed to balance benefit with profit maximization. And China is quite different. I mean, big companies by design are supposed to benefit the common good as interpreted by the CCP, as well as making money for themselves. So
Yeah. Well,
pluses and minuses to that, right? But then you can look at what states of mind people are in when creating these sorts of AI systems, and what sorts of mind interacting with these AI systems put us in, right? Which is quite sort of resonant with the state of mind of the AIs themselves. Like if you look at AI for running social networks, I mean, they tend to fractionate people. They tend to focus you on buying stuff you don't need and on rallying up your righteous indignation and like whatever emotion will keep you glued to that Facebook page for as long as possible. So that's psychology of the current AI industry and the people involved in it. So
yeah,
then you can ask, what sort of singularity will this lead to? What other sort of AI could we be building, resonating with what other states of human consciousness, and what other sorts of singularity could be evolved?
yeah. Well, I mean, you're talking about building minds, and that's why I was. I mean, your book is about the conscious. It's titled "Consciousness Explosion." That's why I was asking about
Yeah, yeah.
consciousness. I mean, why are you using the word mind if you don't believe that a neural network, no matter how big, could become conscious? I mean,
I personally believe that every elementary particle has its own spark of consciousness. So I tend to be pretty strongly panpsychist, and I believe Strawson and other philosophers that this is pretty much the only consistent and coherent way to think about consciousness. And of course, it's a lot of thinking with a long history. You can look at, say, the Buddhist logicians, Dignaga and Dharmakirti from the Middle Ages, laid out a whole theory of mind based on a rational panpsychist view a long time ago. So to me, that's sort of the only coherent premise I know how to begin with, but it doesn't solve everything. Like it could still be that, I mean, okay, if a coffee cup has its own species of consciousness, okay, but it may be a very simplistic species of consciousness that's boring from relative to a human being, right? So then that still doesn't answer you in what sense does a coffee cup feel pain when you cut it in half? Because you could have some forms of consciousness that don't feel pain, like a person with pain asymbolic, right, or a very muted sort of pain. And it does that panpsychism in itself doesn't tell you whether a digital computer that appears to be more aware and generally intelligent than a person is having the same sort of experience that a person is, right? So I mean, I do think everything is conscious, but I think that's only a starting point to investigating consciousness, right? It's not in the finishing point. But I also suspect that if you have a digital system that has the same sort of emergent patterns in its structure and dynamics as a person has, I suspect it will have the same flavor of conscious experience that a person has. I mean, it seems like by far the most straightforward hypothesis. I'm just saying that's an intuition of mine. I've written a bunch about it in this book and elsewhere. I wouldn't say it's nailed down scientifically in the way that we've nailed down that, like, okay, the stars are probably not angels flying around. They're probably giant balls of fire, right? Like or plasma at least. So I mean, we haven't nailed down theories of consciousness to that level yet. So I mean, there may be some big surprises, right? And it'll be interesting to explore them. I think we're going to do experiments with brain-brain interfacing and brain-computer interfacing, which should be quite informative. Like, what happens if you literally wire your brain into the digital neural network of an AI system versus wiring your brain into a neuroid grown in a vat, right? Like, what's the different subjective sense that you get while carrying out these brain machine interfacing experiments. I mean, I think this should be quite informative in a sort of mix of an intuitive and scientific way, and we'll be able to do that during the coming decades, right? So there's going to be a lot of new input coming in to form our particular theories of consciousness, and that's well, yeah. Go on.
Well, I mean, the question of consciousness aside, because I have to say, if you say a coffee cup has some form of consciousness, I think you pretty much drain the word of any real meaning.
Well,
Uh,
why? I mean, a coffee cup is in everything around us is in space and time. Space and time, spatial and temporal properties are immanent in everything. That doesn't mean space and time have no meaning. I look at consciousness just like spatiality and temporality. These are aspects that each thing in our universe has. I mean, they can have different. Something has different spatial locations, has different positionings in time. Different things, their consciousness can have different aspects. It doesn't mean it has no meaning. I mean, at least that's how I look at it.
yeah. So on your AGI work, what kind of paradigm are you pursuing? I mean, there's been right now it's everything's being built off transformer algorithms and neural nets and back propagation and all of that. Are you following that model, or
No,
are you
not at all. No, I mean I'm using those systems, but they're not central to my AGI architectures. I mean, I think I view current large language models and other deep neural nets trained on huge bodies of data as extremely interesting and useful catalogs of human knowledge. And I mean, the fact that you can synthesize stuff out of these knowledge catalogs is amazing, right? I love working with these systems. On the other hand, I think they're doing something very different than a human mind is doing when it's thinking, or than a AGI system really worthy of the name will be doing when it's thinking. So I mean, I think on the other hand, my intuition is you could automate 80 or 90% of the human economy using LLMs and CNNs and similar technology. So I mean, I think there's a huge economic revolution and humanitarian revolution that can happen from these systems. I don't think these systems can ever be creative or original in the way that people are. That's just not what they're doing. They're combining a whole bunch of knowledge on a surface level. On the other hand, most economic activity does not involve a great amount of creativity or originality either,
you?
right? Most economic activity is rote and is doing small variations on stuff that's been done before. So then, I mean, you can automate it with these technologies as hardware gets optimized and the software is optimized. That'll become cheaper than having humans do this. So from a business view, I can totally see why businesses want to focus on this technology because it's there, it works, you can scale it up, you can bring the price down, you can improve reliability, and then you can automate almost all of the world economy. So then in that sense, why would you worry about doing R&D aimed at automating the last 10% of the world economy or transforming humanity in some way, right? There's so much money to be made and so much good to be done, right? I mean, I think you could automate so much medical research using LLMs and then I mean you can automate supply chains to deliver food to the impoverished. Like there's great stuff to do with them. Bottom line is though, I mean they're so far they're not agents. Like they don't try to understand who they are and who you are and what is their position in the world. And they don't abstract knowledge very well. They abstract knowledge a little bit, but they're mostly just building surface level indexes of detailed knowledge. And I think that making leaps of creative generalization and imagination, making leaps beyond your knowledge, is done via having abstracted your knowledge. And these systems aren't doing that. And agency and abstraction come together in human minds, right? Like we form abstractions not arbitrarily, but we form the abstractions of our detailed knowledge that will help us achieve our goals as an agent in the world and help us maintain our boundaries and existence as an agent in the world, help us grow and develop as an agent in the world, right? The need to grow, develop, survive, achieve goals is what drives us to make mostly appropriate abstractions. We then use these abstractions to drive creative generalization, right? And all that stuff is missing in current LLMs. And you can't just wrap an LLM in like an agent wrapper. People tried that with baby AGI and so forth right after GPT-3 came out. You
Mhm.
can't just wrap an LLM in an agent architecture and have it be an actual agent in the way that people are. I mean, you need a whole different way to think about knowledge and the representation between knowledge, memory, and learning and so forth. So yeah, we're in the OpenCog Hyperon project, which is my main attempt to build AGI. We are taking a quite different approach. I mean, we start in a way from human cognitive science and the different kinds of memory and reasoning that the human mind seems to have, like episodic memory, declarative memory, procedural memory, working versus midterm versus long-term memory, and the different sorts of goals and different timescales that we have. But then we're not trying to emulate precisely how the brain works. Instead, we're taking the different key types of memory and learning and reasoning and processing that seem to be done in the human mind, and we're realizing these using a diversity of mathematical and computer science algorithms. So on the software level, we have a large distributed knowledge graph, or knowledge metagraph more properly, and we represent both perception, action, reasoning, learning, different types of memory as different sorts of organization within this large distributed knowledge graph, which can then rewrite and modify itself in the course of its thinking. And we then have a blockchain software layer that lets this whole knowledge graph run on a decentralized network of machines without any central owner or controller. Now you can have transformer type stuff in there as part of that, because these networks are very good at recognizing patterns in data, right? But in our approach, recognizing patterns in data is not the whole thing. And you can, if you look at something called the Common Model of Cognition that was put out there by Paul Rosenblum and John Laird and others, who have been sort of good old-fashioned AI guys, even longer than me, they try to articulate what are the key aspects of human cognitive science that we need to put into an AI if we want it to be human-like. And you can see that current deep neural net systems being used in the commercial world, I mean, they cover only a quite small percentage of the different kinds of things that seem to happen inside the human mind. But we are, so relative to this deep neural net approach, we're pretty far out there. Relative to Penrose and Hameroff, I mean, we're building stuff in digital computers. So I mean, in that sense, we're relatively close to the mainstream. We're acting under the premise that by putting stuff on a large, distributed, decentralized network of digital computers, we can create something that thinks better than people. Now, I mean, I've done a bunch of work in quantum computing theory too. So I think once we have like QPUs, we have quantum processing units to plug in on our server farms. I mean, I think we can upgrade many of these algorithms in a very interesting way. Like it's not that I think that won't contribute something, but I think it's probably not necessary to get superhuman general intelligence, and probably not necessary to get intensive subjective experience in the AI either. Although the latter part, again, is a bit less certain since we don't have a real theory of experience.
Yeah. So the knowledge, let's start with the knowledge graph. How do you build this knowledge graph? Your business is ready to launch, but what's the most important thing to do before those doors open? Getting more social media followers, or actually legitimizing and protecting the business you've been busy building? Make it official with LegalZoom. As a business owner, traditional legal services come with major sticker shock. Getting registered or talking to an attorney shouldn't have to cost you so much. Well, thankfully, today's sponsor, LegalZoom, created a better way to start and stay in business from initial formation to one-to-one legal consultation. I've used LegalZoom for over 10 years, and it's kept me compliant. They have Everything you need to launch, run, and protect your business all in one place. Setting up your business properly and remaining compliant are things you want to get right from the get-go, but you don't have to strain your brain or wallet. LegalZoom saves you from wasting hours making sense of the legal stuff. At LegalZoom.com, you can take care of business legal needs in just a few clicks. And if you need some hands-on help, their network of experienced attorneys from around the country has your back. Launch, run, and protect your business to make it official today at LegalZoom.com and use promo code SMITH10 to get 10% off any LegalZoom business formation product, excluding subscriptions and renewals. This offer expires at the end of the year. Get everything you need from setup to success at LegalZoom.com and use promo code SMITH10. That's SMITH10. LegalZoom.com and use promo code SMITH10. SMITH10.
Oh, for me, I mean, there are two ways, or three, I guess. The number one way has to be from experience, just from perception of the world. I mean, percepts come into the graph, patterns are recognized in those percepts, and you have the formation of a hierarchy and hierarchy of patterns inside that knowledge graph. But you can also form a knowledge graph from reading text, and we use LLMs for that. So we use prompting and fine tuning of open source large language models to build knowledge graphs from existing text and from existing structures data. So we have a huge like bio knowledge graph that we got from a bunch of biology data sets and biontologies and so forth. And you can cross link all these things together. I mean, you could build a purely experiential learning system that just builds its knowledge graph from low level perception. And we're experimenting with that a bit actually, but it seems like if you take the view that there's an AGI race going on and your competitors are $1 trillion companies, you may be able to advance faster by taking direct experience and combining it together with knowledge graphs you can download and sort of cross-linking it all in a distributed system.
Yeah, and so how are you on the direct experience accumulation? You're talking about cameras.
Yeah. Actually, let me let me briefly introduce you to one of my friends here in the office. So we've got this little guy here for example. So this is a in progress version of one of our mind children robots that we're building here in our little office in this Seattle area. So I mean I've been working with Hanson Robotics for a long time, as you know. So we had the Sophia robot, Desdemona, and so forth, and we're still working with the larger humanoid robots from Hanson Robotics, which is great. But I wanted something smaller and simpler that I could just have in my house or classroom, and recharges itself when it runs out of power, like a Roomba, and is a little smaller and simpler to deal with than the Hanson robot. So yeah, I don't think you need a human-like robotic embodiment necessarily to get to human level AGI. I mean, that robot I just showed you will have a human-like face, somewhat similar to a Hanson robot when it's all put together. But I don't think you don't need that for human level AGI. On the other hand, it's very convenient, right? Because we're trying to teach the robot ourselves as humans. So to the extent that the robot is embodied in the same world that we're embodied in on a sort of pragmatic basis, the communication pipeline, both content wise and emotionally and self and other modeling wise, like it's clear if the robot is right there in your house while you play with your kids and your dog, and right there in the classroom. So I think there's something to be gained from that. We also have a virtual environment though called Sophiaverse, and we're building a sort of AGI preschool in there. So some things you can get from robots that are hard to get in the virtual world. Some things are easier to get in the virtual world because virtual characters are more capable than current robots. And then there's a lot of learning an AI system can do by proving math theorems or analyzing biology data sets and doing other things that are not so much similar to the way a human interfaces with the world.
Right. But for the direct experience, so you have a robot, has cameras for eyes, presumably it's got microphones for ears,
Yep.
some
There's
haptics,
some skin. We got some haptic. Yeah, some skin too. That's right. Yeah.
yeah, for touch, and as it uh, manipulates objects or moves around within an environment, what's happening with that data stream that's coming in?
Well, what we're doing right now, we're feeding that data stream into deep neural networks, and then those deep neural networks are connected with the OpenCog Hyperon knowledge graph. So we can, and I mean, it gets technical, but I mean, we can represent parts of the torch compute graph for the neural net as nodes and symbolic nodes and links inside the OpenCog atom space knowledge graph, and then patterns of activation, patterns of activity in the deep neural network are then represented as nodes and links in the symbolic system. So the approach to perception is heavily neural symbolic, and similarly on the action side. So to train a particular action, like a hand picking up some object, we're using deep reinforcement learning to train a neural network. But then that reinforcement learning network is linked into the symbolic network, which deals with higher level planning. So, like if the robot is planning to go into the other room and get something and bring it back to you, that planning happens on the symbolic level, but the specific movements of the arms or the head is done by a neural net trained by deep reinforcement learning. And then we have some unique ways to connect what happens inside these deep neural networks, what happens inside the symbolic knowledge graph, and which is, I think you could do the perception and action purely symbolically also if you wanted to. I mean, there's no reason that the the luminosity and hue on a pixel can't be represented as a logical atom in a logical knowledge graph. It's just there's a certain degree of pragmatism here, right? Like we have nicely working systems for arm movement and visual and auditory perception due to the amazing work of other people. These are deep neural networks, right? So why not just link these into our symbolic knowledge graph, which can do things that deep neural nets are not now good at, and use the deep neural nets for what they are good at. And I mean this comes is highlights the point that there's going to be a lot of different ways to make AGI systems, right? Like, while I'm not working on neural net centered systems now, I totally think you could make a human level AGI, putting together a bunch of different formal neural networks. I mean, that's what DeepMind is trying to do. I don't see why that wouldn't work. It's not what interests me most for a couple reasons. Like, I think that neurons and neural networks evolved to be very efficient on biological wetware, and they're not necessarily the cleverest way to leverage modern computing hardware, which is quite different than biological wetware. I also think humans are not that good at reasoning in the end, and we're not that good at ethics either. We're wildly inconsistent. So I think it's interesting to make a system that empathizes with humans and resonates emotionally with humans, but can do science and math at a much higher level than human beings can. And this is a big disagreement with me and Penrose, we mentioned earlier in the conversation. Like, he thinks the quantum gravity voodoo in the brain makes us better than any digital computer at doing mathematics, and I'm almost sure that's exactly opposite from the truth. Like, I think what's happening in the human brain is really cool, but I mean, I think that digital computers are going to be tremendously better than us at mathematics, in the same way they're now tremendously better than us at chess and Go. Right? I mean, math is also a formal manipulation game, albeit a much bigger and more flexible one. So I don't. I mean, emulating exactly how a human brain works is really, really interesting, right? It's a computational neuroscience problem, and I think we will be better off to have some advances in brain imaging before we full on attack that problem. Building a super AGI doesn't necessarily require us to emulate exactly what's happening in the human brain. I mean, any more than building a jet requires us to exactly emulate what happens in an eagle's wing, which we still don't fully understand.
Yeah. You've got this data flowing in, and you're building this ever increasing knowledge graph of representations. These are vectors in effect that
Mhm.
that that you're getting from the data stream that are there.
I would calling them vectors is not quite right. Although you can embed them as vectors, but I mean it's weighted labeled nodes and links, right? And that they can be there's links going between nodes. You have links going between two, three, four, five, or 100 nodes. You can have links going to links or subgraphs. You can have types on the links in the sense of functional programming languages. You could also have vectorial labels on links, but it's not primarily a vector based model though.
And then what happens? So you are building that now, that
We
graph.
have that, yeah,
Yeah. And then do you have a, a model then that queries that graph and
yeah,
calculates answers out of it? And what's that
sure.
model?
There are multiple, but yeah, I mean, so we have our own AI programming language called Meta with two T's, METTA, which is Meta Type Talk, and also means loving kindness in some species of Buddhism. So this programming language is basically isomorphic to the knowledge metagraph itself, right? And so you can use that as a query language, like Neo4j's cipher graph query language or something. But we have a probabilistic logic engine called PLM, probabilistic logic networks, and you can make queries of the knowledge graph, and it will do some probabilistic and fuzzy higher order logic reasoning to try to come up with answers to your queries. Now, if it can't find the answer, there are then heuristics for creating new concepts, say by blending together existing concepts, or you can do evolutionary learning, like a sort of probabilistically enhanced genetic programming. You can use evolutionary learning to learn new patterns and procedures. The data that feeds the evolutionary learning is in the knowledge graph. The programs and patterns learned by evolutioning are in the knowledge graph. The evolutionary algorithm itself is just another chunk of knowledge graph also, right? So you can do probabilistic fuzzy reasoning to answer questions. Then you can do various sorts of concept creation and pattern recognition things to try to build new knowledge to be accessed by the probabilistic reasoning engine that tries to answer your questions. And then there's an explicit motivational system where there's a certain set of goals, and the system is expending a certain percent of its resources trying to learn procedures that it probabilistically believes will help it achieve its goals in the current context. And not all of the dynamics is goal driven. Some of it's goal driven. Some is just spontaneous node and link building and activation spreading and so forth.
Yeah.
So at that level, we're roughly trying to emulate human and animal motivational systems, but not in every precise detail, because I think in some ways that would be undesirable. I don't want a super AI that behaves exactly like a human, right? And
Yeah.
then yeah, there's subtle questions here, like do you let the system replace its top level goals as it gets smarter or not, right? I mean, the system certainly would allow that. The top level goals are just cognitive content in the knowledge graph along with everything else.
And what's the interface that you're using to to interact with this system? Is it a web based text box? Is it
Um, at the most fundamental level, the interface is programmatic, right? I mean, the interface is meta code, is code in our own language, and then you have a shell, and you can interface via that programming shell, much like in Lisp or something. On the other hand, of course, there's a variety of other interfaces you can build. I mean, you can have a natural language interface, which is basically chatting with an LLM, which is then connected to the knowledge graph on the back end, right? And so you can do that, and or you can have a robot interface, or a virtual character interface or something. So I mean, again, fundamentally for a transformer neural net like ChatGPT or Llama or something, the fundamental interface there is you feed a sequence of tokens, and then it outputs a probabilistically weighted set
Mhm.
of next tokens, right? And that's the core interface. Then on top of that, they use instruction tuning to build this dialogue system, right? So our core interface is not next token prediction. Our core interface is just running scripts in the meta programming language, which is isomorphic to the graph. But then you can build a lot of different end user interfaces on top of that.
Have you? Are there? I mean, is this something that that people can interact with? That you have?
We've not rolled this out as a product yet. No, that's it's
I
alpha.
don't mean as a product, but as a as a something that people can see and interact with. Just
Not
on,
yet. No, I mean, it's open source code. So for developers, yeah, developers could download and interact with the system. But we haven't made a public end user interface to the thing yet, mostly for performance reasons. So we have the alpha version of this OpenCog Hyperon system, and we don't. Most of the work between alpha and beta is massively speeding up and decreasing the resource utilization of the back end, because right now it just runs slowly and takes a huge amount of resources. So if you open it up, you would need to dedicate a number of servers to each person who's interacting with it. But we're we're making good progress. I mean, our current new prototype version of the meta language interpreter is like a million times faster than the public alpha version, right? So I mean, I think we should be, by early next year, we should have a vastly more performant version of all this infrastructure, which will then obviously, like, that's when the research gets super interesting, right? Because then because right now we can either have a large knowledge graph or we can have fast interaction, but we can't have both. And I think we will have solved that by sometime around the end of this year, and then we're sort of off to the races, right? And it's been like 2 years of work just building this infrastructure for this new version of OpenCog, because we had an AI project, like we started OpenCog in 2008 based on code that was around since 2001 or something. We did a lot of interesting research about the back ends of some commercial systems, including parts of the back end of the Hanson robots and some stuff in biology and financial trading and blah blah blah. But we couldn't scale it up to the level that transformers are scaled up. So
yeah.
we've been spending 2 years working on building scalable infrastructure so we can explore the hypothesis that when we take this OpenCog flavor of AI and run it at a GPT-4 like scale, like then we can get amazing, unprecedented things to happen. Because that is one of the big lessons from LLMs, right? Like you take some old stuff, tweak it a little bit, run it at massive scale, and it does way better things. So
If if
we
it's
have
scale,
we have some reasons to believe that could work with our flavor of AI also. That when you just start running it on a massively bigger scale, it will start to do a lot of more interesting things also.
yeah. And how are you financing all this? I remember you guys did a
Token sale.
ICO, yeah, yeah, back in
Yeah.
2017 or something.
Yeah, we're financing all this work primarily. via tokenomics and the cryptocurrency world. So yeah, I mean we still have the liquid token. That was the AGI token we did it ICO for in 2017. We've now merged SingularityNET token with the tokens of Fetch.ai and Ocean Protocol into the new ASI token. And then we have some AI services running on SingularityNet platform that you pay to use them in the ASI token. And we then have some spin-off projects using this decentralized AI platform for things in decentralized finance and medicine and so forth. We do also we have a traditional for-profit company called True AGI, which has raised a bit of equity investment and is aimed at wrapping up OpenCog Hyperon for the enterprise. So there's some of that like traditional venture investment aimed at SaaS products, but the majority of the financing is from the cryptocurrency world. And then, of course, all this is open source, and we have some element of just random AGI enthusiasts contributing to the code base also. But yeah, we've managed to do this all open source and fully decentralized by sort of bypassing the putting Silicon Valley VCs and such at the center of it, which was important to me. Like I'm an old school open source zealot.
Yeah, and the how big was that ICO? And then, of course, cryptos crashed shortly after that. And I remember thinking of you when uh, cryptocurrencies sort of deflated. Uh, uh,
Well, they've gone up and down many times since then. It's a very volatile market. Yeah, yeah. I mean, all all AI crypto tokens went up in price considerably when ChatGPT came out. Actually, so since that time has been a more favorable time for AI oriented cryptocurrencies. But I mean, we've basically kept our AI team fed and productively working through the ups and downs of the crypto markets. I mean, that was a like $36 million token sale in 2017, I guess. But I mean that's ancient history. We've had a whole lot of other crypto token things, both good and bad, happen since that point in time.
yeah, but then do you when as you need capital, do you convert uh, your cryptocurrency to U.S. dollars or whatever
We can
currency?
do that. I mean, not that many U.S. dollars involved because our team is mostly not in U.S. and many developers are happy to be paid in crypto tokens for the work they do. So you don't always need to convert to fiat money either.
Yeah, that's fascinating. So, yeah, I mean, what do you want listeners to take away
Well,
from this?
there's one other brief point I didn't get to make about consciousness, which I'll take 30 seconds or a minute to make. So I outline what I see as the state of consciousness of current corporate AI systems and the human state of consciousness that they tend to lead to. So my perspective is if to the extent that humanity can shift to a more open, peaceful, and compassionate state of consciousness, which we humans manage to do sometimes, right? I mean, you can meditate, it can help you get there, but there's no magic bullet for it. But of course, humans at our best, we can be compassionate, lovable, open-minded, non-attached, wonderful creatures, right? And the extent to which we can verge into these states of consciousness and infuse this into the AI systems that we're building, I think this will lead us toward a happy singularity, to a far more with a far higher probability. Like we want to infuse the AIs we're building with our best selves, with our best states of mind, with the most wonderful, joyous state of mind we can get into when we gather together. We don't want to infuse the AGIs we're building with the states of mind that we get into when we're trying to defeat the other team and deprive them of all their resources and manipulate them into doing stuff that's not for their own good, right? So we need to be guiding ourselves into our best states of mind individually and collectively, and then interacting with AIs in this vibe as we improve the AI technology and rolled out in different applications. And this is going to be very, very important for making the first AGIs and superintelligences warm, compassionate, beneficial, open-minded creatures. I mean, very much like when you raise children, and I've got 5 children and 1 granddaughter. Like when you raise children, what you tell them is one thing, but if you sort of emanate sort of an ambiance of kindness, compassion, and openness when you're interacting with them, when they watch you interacting with others, when you're doing things together with them, this makes way more difference than any rules you lay down, and way more difference than what you're telling them to do, right? And that's not what we're doing in the AI industry right now. It is very much what we should be doing, and I talk a lot more about this in the consciousness explosion. Like, how do we guide the AIs we're building into the most positive sorts of state of consciousness that we as the human species understand? And that's the kind of thing that's not being thought about enough, really, because the AI industry is all about how does one company make more money than another one, right? And that's something to think about. And you go to the consciousnessexplosion.ai. You can download the book for free in PDF or find your way to the Kindle hardcover or paperback versions. Also, take a look at my website, Goertzel.org or SingularityNET.io, superintelligence.io. Plenty of information online to follow up on all the themes we've been discussing today.